let's talk a little bit about the work sequences. You've all heard about first in, first out. That's FIFO. Yes, but if we put it in a 2x2 matrix and we manage all the combinations, you can have last in, last out, which would be LILO, first in, last out, which would be FILO, and we have last in, first out, which would be LIFO. Wait a second. We'll go back to this later on. We can also have the first delivery date, which one comes sooner. That's the one that we work first. We can have shortened processing time. Those that are done faster, take them out of the way so that we can concentrate on other stuff. We can concentrate on those that are more complex and demanding, longer processing time, or the degree of difficulty, either minor or major. We decide using our critical success factors. But allow me to come back to these 4. If you check out, first in, first out is the same as last in, last out. I will use the example of an elevator. Elevator? No. In this case of these two, it would be just a queue. The first in is the first out. The last person who arrives would be the last out in a queue, a normal queue. In the second case, I will use the case of the elevator. The first people in goes to the farthest part of the elevator, is the last one out. But the last one in, it's closer to the door, is the first one out. So, instead of having these 4, you only have 2, FIFO and LIFO. Those are the only 2s. The other 2s are just repetitions of the same. You don't need to learn all 4 of them. Just FIFO and LIFO. First in, first out, last in, first out, period. Now, we have another aspect that we use when we're controlling production, the critical index. And that is calculated by taking the difference between the delivery date and the current date and dividing it by the remaining work time for delivery to the customer. There are 3 possible results for this. Either it's below 1, in which case we are behind what we have programmed. It's exactly equal to 1, which is according to what we have programmed, or it's greater than 1. In that case, we're ahead. I'm not questioning right now why it's happening. I'm just saying these are the 3 values, and you need to know them in order to be able to act accordingly. How do we program in the manufacturing sector? First, if possible, eliminate bottlenecks. Always take into account the restrictions imposed by reality. You need to know well and very thoroughly the elements that you have. You have to accommodate creatively things in order to produce as much as possible. But check this out. We're talking about information. We're talking about knowing your reality. We're talking about creativity. You can learn things in theory, but you need to apply all of them and to apply them with a lot of criteria. And that is only gained by practicing and understanding that most of these things, the correct application of the combination of all of them is more of an art than a science. In the service sector, we have almost no capacity to generate inventories. So, if you remember the operations triangle, we have to solve the problem either through knowledge or capacity. The usual ways are appointment systems, are FIFO, first in, first out, are reservation systems. But the question about the reservation system, is it not the same as the appointment system? You're reserving a time slot. That's an appointment. Usually, for example, in hospitals, we can only use capacity as a parameter in emergencies. For normal services, we use an appointment scheme, that is knowledge. In banks, we cross-train our people so that we can relocate them depending on demand. This allows us to simulate a variable capacity. In airlines, we can only use knowledge to make better use of our capacity. We can have variable capacity if we use charters, that is, if we put more planes. So, since we cannot change the capacity easily, that's why we overbook and then we pay for the people who come and who cannot fly. Cyclic programming. We shift over time the programming by a certain time of units. It is very simple, it is very predictable, flexible, and people love it. Let's give you an example. In this case, everybody will be working one shift on and one shift off. So, Paul works on Monday, rests on Tuesday, works on Monday, rests on Tuesday, Friday works, as you can see, works on Monday, Wednesday, Friday, Sunday. It's one on, one off. Rows, the same, but displaced by one day. Peter repeats the same as Paul, the same as John. Oh, I hadn't noticed, but all the men work in one shift and all the women work in another. I'm going to have to check this out for the following version. So, they work one, they rest one. Now what happens if I work with 3 on, 3 off? Well, in this case, we work 3 days and I rested 3 days and then I work 3 days. Rose does the same but displaced by just 1 day. Then goes Peter. As you can see, this is something that everybody can very easily understand. And that's something that they like. Why? Because then Rose can switch their programming with another worker when she needs. For whatever reason, she cannot work this shift, she can change it with the other one. And everybody sees it as equitable. That is cyclic programming. So, now to close, let's check out the key points that we have seen. Programming concepts, we saw the difference between aggregate planning, framework programming, short-term programming. Why is short-term programming so relevant? Adaptability, costs, time, and reliability. We saw forward and backward programming. We saw the programming criteria. Required information, input-output control, work sequences, critical index, minus, equal, or greater than 1. programming in the manufacturing sector, programming in the service sector, cyclic programming, and capacity planning. As always, I thank you for your attention, and I will be seeing you in the next video of this series. Bye.